All right, everybody, how you doing today? Today we're going to be talking about solving three variable systems. Now, we have talked about systems before, but we were solving a system with only two variables, meaning we had two equations, and a lot of the times our goal was to find the point where the two lines meet. But we also knew that lines may never meet because they're parallel, so we would have no solution, or that lines were identical to each other, so we ended up with infinitely many solutions. The only catch for today is, and this is for the honors level course, the solution to a system of linear equations is a point at which they intersect. So notice that no matter what we're doing, as soon as we say a system, we're still looking for the point of intersection. Now, earlier in the chapter, like we said, we only found a point called x, y, but today we're going to be doing a three variable system. So if you notice, not only are we looking for the x and the y, we're starting to find the letter z as well. Now, if we want to find the answer to three letters, well, then we need three equations, as you can see in some of the examples that are already coming up. So again, our goal is still the same. We're going to look for the point where the three, in this case, lines meet. So we're looking for three variables this time. So let's begin. Now, in order to understand this concept, we're going to start with example number 1, where it says, determine whether each point is a solution for the following system of equations. So what I'm basically asking you here is this the point where these three lines are going to meet? So I'm giving you an x, I'm giving you a y, and I'm giving you a z. And just remember, like in any other math class, if they tell you what x, y, and z are, if they tell you whatever the letter is, what do? Well, plug it in. So all we're going to do is plug in, and we're going to check. We want to make sure that it is a true statement every time I plug it in. But just remember, we're plugging in three separate times. So we're going to start off with our very first equation. 3x plus 2y plus z is equal to 3. But we are going to leave empty spaces for all the letters. So here is that yellow equation to start it off. So it says 3x plus 2y plus z is equal to 3. Notice I said the letters, but I didn't write them in because I need to plug in my numbers. So the very first number that we have here is my x is 0, so we plug it in. My y is 2, and my z is -1. All we're doing is checking. We're checking to make sure these three numbers actually work for the first equation. So 3 times 0 is gone. 4 minus 1 is 3, and 3 equals 3. That is a true statement. So far, so good. Does that mean that this is the point where all three lines intersect? Not quite yet. We still need to check the others. So we go to our second line. And yes, it takes a little while to do, so you don't have too many of these problems to work on. So it says 3x plus 3y plus 3z is equal to 3 again. All right, well, it's time for us to plug in a 0 for the x. My y is 2, and my z is -1. Again, in math, when we give you a value for a letter, your go-to is plug it in, see what happens. So that's what we're doing here. So this is gone. And of course, 3 times 2 is 6. 3 times -1 is -3. And so when we finish it up, 3 equals 3. All right, it's looking good. It has officially worked for two of our equations. Does that make it the solution? No. We have to check the very last one. So here comes our last equation that we're going to double check. So we have enough room here, just enough room to double check our answer. So again, I'm going to copy the equation the way it is. 2x plus 4y plus 2z is equal to 6. Again, I say the letters, but we don't actually write them down because we know they need to be replaced by their official value. So my x is 0, my y is 2, my z is -1. It's great when they use 0 because it just goes away. 4 times 2 is 8. 2 times -1 is -2. 6 is equal to 6. It definitely worked out for all three. So the question asked, is that the point where all three of these lines are going to intersect? And the answer is yes. The fact that we have three true statements, then 0 2, -1 is the solution, right? To that system right there. And there's our answer. They want us to check, is it gonna work or not? Well, in this case, it did. So that was nice and easy to do. All right, moving right along. Well, we have another one here. Normally I would say try it out, but let's just do it together. So, same situation here. We're giving you an X, we're giving you a Y, we're giving you a Z. There's my X, there's my Y, there's my Z. My question is this where all three lines are gonna meet? Well, again, if all I'm doing is checking, then let's start plugging in. So I'll take my first equation. Here we go. All right, 2x plus y plus 7z is equal to 8. All right, let's see. My x is 2, -3 for the y, and a 1 for the z. Let's work it out. 4 minus 3 plus 7 is equal to 8. 4 minus 3 is 1, plus 7, 8 equals 8, absolutely. So we have a true statement. Just gonna write T for short. All right, is that my answer then to the whole system? We don't know yet. We still need to continue to plug in. So here's my second equation. I'm gonna take a moment, write it out, plug in the numbers, of course. So it says 4x plus 3y plus 3z is equal to 4. And we're plugging in the exact same three numbers again. The 2, the -3, and the 1. So we're going to plug in our numbers there. Zoom in a little bit more for you. 4 times 2 is 8. 3 times -3 is -9. Plus 3 is equal to 4. So when I do the math here, 8 and -9 is -1. -1 plus 3 is actually a 2. So the question is, does 2 equal 4? Not at all. We have our first false statement. So now the question is, all right, so it didn't work for this line. So should I even test it in the third one? Yeah, not at all. As soon as it failed one of our lines, then I don't waste my time checking anything else. If it failed, all I'm going to say is 2, -3, 1 is not the solution. Remember, we are just checking. We're not solving. We're not trying to figure out what X, Y, Z are. They're just asking, is this a solution to that system? And the answer is no. Now, these problems were a little bit easier because we were just checking to see if that was the solution. The interesting part comes in when we have to find that point of intersection. So that's what we're going to do now. Just giving you a moment to catch up with the writing there. All right. Now, I'll give you a heads up. You may want to write kind of small as we go. So now we're going to find the answer ourselves. So it says, solve the following system of equations. Now, it does say if possible. Remember, we do have the possibility of no solution or maybe infinite. That is a possibility as well. So it says, solve the following system of equations. Well, it has 3 letters. So if it has 3 letters, don't forget the goal. In fact, I have all this space, but I'm going to write it over here. I'm going to start getting a spot ready for my answer. Remember, my answer are 3 numbers. I've got 3 spaces to fill out. I've got my X, I've got my Y, and I've got my Z. So I'm just going to get that box ready just in case. So I'm just getting my answer box ready. Now, one of the only ways that we can do this, one, we could try substitution, but you can't really get a lot of these letters by themselves. So substitution is not going to work for us. Maybe not until later. So one of the techniques that we're going to use is we are going to use what we call the elimination method. And you should be aware of that one because we've used it already. With elimination, your goal is to get one of the letters by themselves. Well, we have 3 letters, so we're going to do one at a time. Now, I'm going to label these. I'm going to call this number 1, equation number 1, number 2, and number 3. So that when I mention an equation, it'll just be easier for me to say number 1, number 2, and number 3. So I'll start there. All right, let the process of elimination begin. The one I'm going to work with first I'm going to work with equation number 1 and equation number 2. You can only work with 2 at a time. So I'm going to start there. Now, I need to pick a letter to cancel between 1 and 2. We try to usually keep the x. You can get rid of it. You can do whatever you want. The x is easier to cancel out because none of these are opposites. So I'm going to choose to cancel the x. And that's usually your go-to. Just cancel out the x first. Especially when this is new to you, just go with the x first. All right, so I'm going to write my equation. X plus 4y plus 2z is equal to 5. X plus 2y plus z is equal to 1. All right. My goal is I want to cancel, we said, the x. That's the goal. Well, think about it. This is a positive 1. Yes, it's invisible. This is a positive 1, so 1 plus 1 does not go away. That means I want one of these to be a negative. Then I have to multiply everybody by a negative. All right, but I'm going to rewrite it. I don't like just writing things all over, so like putting it out of place. So I'm going to go in order again. It says x plus 4y plus 2z equals 5. All I did was copy number 1 again, equation number 1, but I'm going to fix number 2 now. Negative x, negative times a positive is negative 2y, negative times a positive is negative z, and a negative times a positive is negative 1. Now we're ready. Now keep in mind what we talked about when we were doing systems before. These, yes, they're going to cancel out, but only if you tell people that you are going to combine. So that's what we're going to do here, a little combination. Remember, this is not an equals. We were just rewriting there. So don't got to change that up a little bit there. All right, so here we go. Let's do the math now. X and negative x, gone. 4y minus 2y, 2y. 2z minus 1z is just positive 1z, and it equals a 4. We have now created a brand new equation right here, and I'm going to call this equation number 4 now. See, we already had number 1, number 2, number 3. Well, now we have equation number 4. Notice, there's no letter by itself, so it's not like I found what y is or what z is. You can't solve for 2 letters at a time, but we're getting there. All right, so that's only the first part of the process. And again, we have equation number 1. We had equation number 2. We have equation number 3. But now we have equation number 4. So we do have a brand new equation right here, which we will use later. All right, so step 1 is done. On to step number 2. Step number 2 says, well, if you used 1 and 2, now number 1 is a great equation because it has a single x. So now, give it a little separation here. Now I'm going to work with equation number 1 again and equation number 3. Now remember, my original goal was to cancel x, so I have to do the same. It has to be the same. I'm going to cancel the x for this one as well. All right, so here we go. I'm going to write equation number 1 again. X plus 4y plus 2z is equal to 5. I'm going to write equation number 3, the pink one. 5x plus 6y plus 2z is equal to 7. Just make sure you're copying it down perfectly. Always give it that second look just to make sure, okay, everything's good. But we said we're going to cancel the x. The idea is, if you canceled x in the first step, then you have to cancel x in the next one. You don't have a choice. You have to do it that way. All right, well, if I'm going to cancel out my x's, well, let me look at them. This is a 1x. This is a 5x, so I want opposites. If this is a 5, I want that top one to say negative 5. Well, then, I'm going to multiply the top by negative 5, and I mean everybody gets that negative 5. I want these to cancel. All right, so I'm going to rewrite it. Yeah, not in equals. I'm just rewriting. Just need some space. All right, here we go. Negative 5 times x, negative 5x. Negative 5 times 4, negative 20. Negative 5 times 2, negative 10, with a z, of course, equals Negative 5 times 5 is negative 25. You got to take your time with this. One little mistake in the negative, there goes the whole problem, and it's tough. You have to go through each step again and make sure to find your mistake. So take your time. We are not messing with this one, so I'm just going to copy it down. That's why it's better to just write it down, make sure everything lines up, makes it easier on the eyes as well. But there's my equation. Now we can add. Now we can tell people, all right, I'm going to combine these two. All right, look at what happens. The 5s are gone. That's what we wanted. The x's are gone. So now it says negative 20 plus 6 is negative 14y. Negative 10 plus 2 is negative 8z. And it equals negative 25 plus 7 is negative 18. What we just did now, we created now 5, our 5th equation of the problem. That right there is our 5th equation. All right, so I'm going to call it number 5. Okay. We still don't know what any of our letters are. I don't know what X is. I don't know what Y is. I still don't know what Z is. But we're getting closer to that. So now look at what we have here. I already worked with 1 and 2. I worked with 1 and 3. But if you notice, they both gave me equations that now have 2 letters each. So I'm going to work with those letters now. Again, we have to figure out how to break up this page. Luckily for your homework, you'll have plenty of space for it. All right, I worked with 1 and 2. I worked with 1 and 3. Well, now I'm going to work with these 2 new ones that we just created. So the next step is I'm going to work with number 4 and number 5. And all I'm going to do is tell you we are going to cancel Y or Z. Doesn't matter this time. Now you get to pick. You will pick which one. You just want to make it go away. All right, so here's number 4. I'm going to write it down. 2y plus z, the blue one here, is equal to 4. Make sure you didn't leave anything out. The other one is negative 14y minus 8z is equal to negative 18. All right, we get to pick. You are going to pick which letter would be easier to cancel for you. Now, this is a negative 14. So if I want to turn this into a 14, well, then I'll multiply by 7. This is a negative 8. Well, I want this to say a positive 8. Well, then I can multiply everybody by 8. So again, it really just depends on which one you want to solve for. And it doesn't matter which one. You'll still get the same answer. In fact, you know what? Let's get rid of the y. I'm going to pick the y. But again, I just showed you do have options. But if I chose the y to cancel out, because it could be the x or the y, but I'm choosing the y for this one, then all I have to do is multiply that top line by 7, we said. And then we write it out again. I know, low on space, everybody. Low on space here. 7 times 2 is 14. 7 times 1z is 7z. 7 times 4 is 28. And then the bottom one, I just copy it down. Just make sure you don't leave anything out. So minus 8z is equal to negative 18. All right, we're ready here. All I have to do is just combine it. So there's my plus sign. Here we go. This is gone. That's what we wanted. 7z minus 8z is negative z is equal to 28 minus 18 is 10. Now, it looks like z is by itself. Well, technically not. Now, I'm at a space here. So, I'm just going to bring it over here. So if it says negative z is equal to 10, well then look, all I have to do is divide by negative 1, and we get z is equal to negative 10, and we have one of our answers, negative 10. All right, now we're getting there. So we have negative 10 available. So that means if you know what a letter is, what do? You plug it back in. So now this is where all we do is plug in, plug in, plug in. So we know what z is. We've got that answer. Well, then plug it in. Now remember, I don't want to plug it into any of these because these have x's. I don't know what x is. But look at these two equations, number 4 and number 5. Number 4 has a z in it and only the y. Number 5 has a z in it with a y. So I can use one of those two equations to solve for it. All right, well then, I think I'm going to go with number 4. That's like the smaller set of numbers there. So I'm going to pick number 4. So I'm going to take equation number 4. And it says 2y plus z is equal to 4. Well then, I'm going to plug it in right there. 2y minus 10 is equal to 4. I'm going to add the 10 to the other side. So now I'm at 14. And then I'm going to divide by 2. We're just solving now. And I get an answer of 7. All right, but there you go. You see, I went and I picked number 4. I could have done the same thing with number 5, but number 5 has big numbers. I'd rather work with the easier one. But now I know what y is, so I plug it in. I've got my 7. Which brings us to finding the x. Well, remember, you can't use these, number 4 and number 5, to find x because it doesn't say x. Now that's where I get to go back to my originals. I'm going to plug in the z, I'm going to plug in the y, but I have to pick one of the originals. And honestly, look, number 2 looks like the easiest. There's an x, a 2y, a z, look, smaller numbers. So I'm going to go back to equation number 2. Again, you can pick any of them. And it says x plus 2y plus z is equal to 1. And now I'm going to plug in x plus 2, the y is 7, plus the z, well, that's negative 10, so maybe I should have just said minus 10, is equal to 1. So it says x plus 14 minus 10 is 1. X plus 4, because you got to combine your like terms, is equal to 1. And here it is, finally, after all this work, and that's why you have to be very careful. Take your time. You don't want to make one little mistake because then it's hard to find. Subtract your 4 to both sides, and your x is negative 3. And just like that, using elimination over here, but then using substitution, aka plugging in, we get our answer of negative 3. So where do these three lines meet? Negative 3, comma 7, comma negative 10. That's where these values end up, or sorry, that's where these lines end up meeting. All right, good times, everybody. Look at the amount of work it takes. So that's why please understand that for today's homework, you're not going to get a lot of these. They take a while. You're going to get like 2 or 3 maybe to practice. All right, and then look at this one. Same thing, look at number 4. When you start looking at number 4, I'm just leaving it up there a little bit longer in case people are writing. Here we go again. We want to find out where these 3 lines are going to intersect. And if you're thinking, dude, what's up with all this space? Well, let's find out. Let's just go with the flow. We have to do exactly what they told us to do. All right, so here we go. We're going to have to use up any space possible, okay? Now, last time I called it line 1, line 2, line 3. Really, you could put it in any order you want. I like this one to be line 1 because it does have a 1x. So a 1x is easy to manipulate. So I'm going to call this number 2 and number 3. Again, it does not have to be in that order. You can put them in any order you want. All right, here we go. Here goes the process like we did before. I'm going to work with number 1 and number 2. And my goal, cancel the x. All right, let me write them down. Number 1 says x minus 2y plus z is equal to 3. Negative 3x plus 6y minus 3z is equal to negative 9. Okay, all I did was copy it. Just make sure, double check, that you wrote everything down the way it's supposed to be, especially those negatives. Now, my goal was cancel the x first. So my job is to cancel the x. All right, but if this has a negative 3, think about it. What do I want to have up there? And if you're thinking I need a positive 3, that's right. I need a positive 3 up there. Well, then let me multiply it by positive 3. So here we go. I'm going to rewrite it all. It's better to rewrite. You avoid the mistakes that may come with this. All right, 3 times x is 3x. 3 times negative 2 is negative 6y. 3 times z is positive 3z. And 3 times 3 is a 9 after the equals. We said we're not going to mess with this one, so just keep writing it down. Exactly the way it is. Don't leave anything out by accident. Negative 9, there we go. Okay, look at that. My goal was to cancel out the x's. One's a positive 3, one's a negative 3. So now I am going to make it official by doing this. I'm going to tell people that I am adding. I'm going to combine like terms. And when I do that, the 3's are officially gone, which is what I wanted. So now let me do the rest of the math. When I look at this one, negative 6 plus 6. Well, negative 6 plus 6 also goes away. Positive 3 and negative 3, well, that also goes away. But remember, you have to write something. You can't just say, oh, my letters are gone, and then write X, Y, Z. No, everything is gone. So what am I left with? 0. You have to write it down. Now, when I look on this side, 9 minus 9, well, that's also 0. Now, this goes back to what we learned before. When we were doing a system of 2 equations, we said, if all your letters disappear on you, that's not a bad thing. That's a really good thing. That means you're almost done. See, when they all disappear on you, that's when you have, let me bring this back, either no solution or infinitely many. So the fact that 0 does equal 0 and that's a true statement, well, when you get a true statement like this, well, if the option is no solution or infinitely many, well, if it's true, then my answer is infinitely many solutions. So now we see why they only gave us this amount of space, because everything was going to go away. So we should be very happy when all the letters disappear. But remember, when they all disappear, you have 2 options, no solution or infinitely many. And in this case, a true statement means infinite. If it said something like 0 equals, let's say it was 18. 0, 18 is false, then I would have said no solution. All right? So, do they take a while? Absolutely. Look at the work that it took to get the one that actually worked out for us. So please take your time. Please watch out for those negatives. But most importantly, when you're writing down your equation, make sure you're copying it down exactly the way it is and that you're not leaving something out. So when you look at the back side here, you do have 2 problems to try on your own. You do have a lot more space here. But here's what I was trying to show you earlier. You know that your first goal is to cancel out x's. So when I'm looking at my equation, this 2x, yeah, that's the smaller number. It's probably easier to work with. So I'll make that equation 1, equation 2, equation 3. Again, it's up to you. But now you're going to go through the process, the same thing we did on the other side, and work this problem out. But when you look at number 6 is one where you may want to reorder. If you know you want to cancel out an x, this is a negative 1. That's easy to multiply with. Then feel free to call that one number 1 because it's easier to work with. Because you know that equation number 1 is the one you're going to use instantly twice for the first 2 steps. Then you could just go like this if you want, or you could do 2, 3. It doesn't matter. You get to pick who equation number 1 is. So pick the one that lets you turn the x into anything you want. And this, in this case, would be the better choice. All right, you have 2 problems to try out here. The key is going to be up for you so that you can check your answers. But again, please take your time with these. One little error in a negative, there goes the whole problem. All right, with that said, you're also going to be working on today's homework after this, after these 2 problems, where you're going to get a few more of these. But if you start looking at your homework carefully, you're going to notice that it has questions that are going to get you ready for next week's test. So make sure you use the time wisely and that you're getting the work done. Have a wonderful day, everybody.